In this video, we're going to talk about the chain rule. This is one of the most important rules you're going to use in order to differentiate functions. This rule will be applied to a bunch of other rules that are to come, but this is the foundation of so many of those differentiation techniques. So first, let's talk about the formal definition for a chain rule. If y is a differentiable function of u, and u is a differentiable function of x, then y is a differentiable function of x. And dy dx is equal to dy over du times du over dx. Now be mindful. We've been seeing dy dx is the same as y prime, f prime of x. Now notice what you're going to do. And remember what this notation means. This means you're going to take the derivative of y with respect to u, which means your y term is going to be, your y equation is going to have all u's in it. This means you're going to take the derivative of the u with respect to x, which means you'll have a u equals equation with all x's in it. So this is like y equals u's. This is u equals some x's. That's the basic idea. Now I use a little bit of a different little shortcut in order to do chain rule, and then it helps me use my rules that I have listed here on the right side. So the first thing I think about is that if I want to find the derivative of f of x, I take f prime of u times u prime. You see, well, what is u? U is going to be whatever is f of that x function. So it's like a composition of functions in a sense. Now the first rules I usually do when I evaluate this is I look at my function, and usually chain rule happens when you have a composition of functions, and when you have a composition of functions you have a function inside of a function. And one of the more common things that you see when you have this composition of functions is a set of parentheses. So you'll have a set of parentheses to an exponent, or a set of parentheses with a function in front of it, like ln or e to a parentheses to an exponent. So what I do is, the first thing I do is I look for what the input function was. What was that composition of function? So I let u be what's inside the parentheses. And usually you'll see parentheses, and that's your go-to sign that says, okay, chain rule. Then what I do is I find u prime. Remember what u prime would then be, just that prime notation tells you it's a derivative. So you're going to take the derivative of u. Then you're going to rewrite your original expression, your y equals, in terms of u. So it's going to be y with u's. And your u prime was the du dx. What you're going to then do after you rewrite your y in terms of u, you're going to differentiate. So you're going to take the derivative of your y times your u prime. And then the last thing is your final answer shouldn't have u's in them. Your final answer should have the x's. So you're going to substitute back in what you started with. Once you get the hang of it, it's fairly easy, but it's just remembering what you're going to substitute for your u, and then make sure you multiply by u prime. So let's look at an example here. Y is equal to parentheses 2x plus 1 squared. So technically this is like a composition of functions, something squared. And the u is your 2x plus 1. So the first step is let u be what's inside the parentheses. So write that. U is 2x plus 1. I always write this. I always write my u's. I always write my u and my v if it's product rule or a quotient rule. So here in chain rule, I write my u as well. Now we could write it as u prime, but remember u prime is the same thing as du over dx. Du over dx, because we're going to differentiate u with respect to x. So the derivative of 2x plus 1 is 2. Step 1, step 2, right? We just found u prime. Second rule, rewrite y in terms of u. So now I'm going to look at my y, and I'll write this in red. Y is, what was 2x plus 1? Oh, 2x plus 1 was u. So y is u squared. Did we do any derivative on y yet? No. That's what we want to find, dy dx, or y prime. So now using the rule says, well, take the derivative of this. Y prime is 2u, put 1 if you want as the exponent, you don't have to. But then you got to multiply by u prime. Write it, just write it using the rule. Take the derivative and multiply by u prime. Substitute back in. So into the u, you're going to put 2x plus 1. and into the u prime, you're going to put your 2. So you're going to get 2 parentheses 2x plus 1 times u prime 2. So you get 4 2x plus 1, which is really, I'll just write it over here because I ran out of board space, y prime will be 8x plus 4. Now, if you use the techniques that we did previously when we first started to look at derivatives, let's erase this, we can answer this and check to see if the answer is correct. So let's go back to y equals. So it's example 1 another way. So 2x plus 1 squared is not put the square of both of them. It's FOIL. So that's 2x plus 1 times 2x plus 1, which is 4x squared plus 4x plus 1. If you need to work out that FOIL a little bit more to see how I got that, then do it. Now the derivative of 4x squared is 8x. The derivative of 4x is 4. The derivative of 1 is 0. Notice we get y prime to be 8x plus 4, which is the same thing we got by using the chain rule. Now you may say, well, that's so much easier. Yes, but sometimes, most of the time, you can't rewrite it. The questions be more complicated, like a negative exponent. Or let's say that was raised to the 100th power. Then you'd have to use the chain rule. So let's look at a few more examples so you can see how this can be applied. Let's try this example. Y is equal to x to the third minus 1 raised to the 7th power. Find y prime. Now, you could expand this 7 times, but that's crazy. You have the chain rule. So first step, let u be what's inside that parentheses. So u is x to the third minus 1. U prime, or du over dx, I'm going to write the du dx, u prime, they mean the same thing, is 3x squared. Now you're going to use this stuff, this information here, to help you find your derivative of y. Notice, remember the rule, said dy dx is equal to dy du, so the derivative of y with respect to u, times du dx, so derivative of u with respect to x. We just did du dx. Third step, rewrite y in terms of u. So y is equal to u to the 7th. Oh, that's going to give you your dy du, the derivative of y with respect to u. So let's take the derivative. Y prime is 7u to the 6th times u prime. It's not u to the 1 power, it's u prime, or du dx. Remember, that's your chain rule. The other way we wrote it, f prime of u times u prime. So now, last step, substitute in. The u is x to the third minus 1. That's being raised to the 6th power. There's a 7 coefficient in front. U prime is 3x squared. Clean this up a little. There's multiplication here. The 7 and the 3 can be multiplied together, and I would push the x squared in front. So my final answer for y prime would be 21x squared, x to the third minus 1 to the 6th. And that's your y prime using the chain rule.